Welcome guys, we are live. So we will continue yesterday's stream to debug the CGANs. So we have here the CGAN file, and in this file we have implemented this CGAN and C linear discriminator, generator and discriminator. But we use this max out. Yep. So we use here max out, but eventually I then just ignore this max out layers. Because I believe they are not that useful. We can ignore them. Okay, 5,000 and then 50. And we add. This is our implementation. Basically. This is code to get the data. And okay, this is our negative log likelihood, batch size, etc. I think we need to make batch size smaller. So let's check it. Yeah, discriminator is training very well. Decrease to 0. Generator also learned. Discriminator also learned. What we can say about this one? This is this okay. -0. -0 means it perfectly learned. This means 0. It is 0. We have guests today at my house. So here I think one option is that our discriminator has good strong ability, strong skill, strong learning ability, but the generator doesn't have. Maybe that's the point. Let's check the number of parameters here. we checked it right yesterday, and what was it? Was 20,000, 20,000, 10,000, and then yes, okay, L1, L2, YL1, and then concatenate, and then L2. How many we have here? Good question. So it means 2,000 multiplied by 784. What is that? So 1,200 and then 784. One 2,000 and 784. Okay, we have 940,800. Maybe the size of generator is bigger and size of discriminator is unequal. So what we will do now, let's try to match them. Let's increase to the 1,000. So then we will have 784,100,000. This much parameter. No. This much parameter. Okay, this much parameter. Then here we have actually plus 1,000, and it will be 785,000. Okay, and here 1050, right? 1050, 500, 500 plus 50, 550 parameters. Maybe this is small. Let's compare here. Let's compare to here. In Y we have 10,000 to 200, 10 to 200. Let's make it same. Okay, let's try to dive more on this, and then it will be 2020. 2,200. Okay, then I'm ignoring max out. I know it's a bit unclear. It might be a bit messy. Please ignore this stuff. We need to prove the max out. And then in here we are saying 200 plus 1,000. Then output dimension is it's 2. Then what we will have is that 2 times 1,200 plus 2. It will be 2,402. Okay. Then does it match? It seems like no. 784, 785 plus 2220, 220, and then 2402. Oh, we need more. We need more. Then let's try to match them. Okay. For example, let's say I will increase here. It's just my intuition saying like, let's try to match him. So how many we need more? How many? So we need more, like 2,000. Like we need we need 200,000 approximately more parameters. So let's say if I have 1,200 times 784 plus 1200. Okay, this matches, but it makes it a bit more. Okay. So let's try with this way. No. Let's make it nicer. Okay. It is raining outside. It is such cool weather. You don't believe? $4,000. It's just a little bit more, you know. What about this one? I mean, let's just keep it 1 and 2, 1,200. I mean, it's a bit more, you know. But our printing output is a bit, it's a bit messy. I admit, I acknowledge it. Let's say for k, and if k divided by 100, no, let 10 equal to 0, then print, okay? And then here also. It is Sunday morning. If k divided by 10 equal to 0, and then print it, and average loss. And I want you to print not just loss, I want you print this f string, and then I want you to say me k iteration, and then you need to say me the n iter, and then this is generator, right? G is equal to this loss, and we want to say loss to f is enough. I mean, I'm reducing the overall size, and then we forgot to add this one, and then seems fine. Seems fine, but this loss is what? Do you think? I think this loss is, you know, maybe it is torch stuff. No, it's just integer. It's just integers, and if it is just integers, then it's fine. Then it's fine, totally fine. F string, and then this guy, and then k, and then we need the n iter, then discriminator. We have a loss to d, no, to f. F means floating points. Okay, so makes sense. Actually, and eventually here average discriminator loss. Let's add here the epoch. Okay, it's good to see the epoch number. Epoch, and let's type it here, epoch, and then seems fine. Yes, for epoch range 100. My learning rate, let me to check my learning rate previously when I trained just my GAN model. Swim GAN in torch. Okay, here 30. Oh, Guys, can you hear me? We have some dropped frames. Maybe it's because of rain or because of the military planes passing away. Momentum. Maybe we don't need momentum. Actually, you know, I don't like stochastic gradient descent that much. We can replace. We can definitely replace. We can definitely replace. My roommate is laughing. I don't know. Python CGAN. Okay, we don't know what is K. Yep, simple. It's simple bug. I know there are a lot of bugs, and we should not waste our valuable time. So if K. And actually, guys, can you see my screen? We need to write code nicely, and we need to write the code. How can I say, carefully, and but with big ambitions, with good intelligence. So our discriminator is becoming less. Generator is also learning very well. Discriminator again. I mean, this seems like they are not learning very well. Actually, let me make this bigger. Let me to check the results. I remember when I trained this simple GAN model, one big problem I had is that just my model size was so big. Let me to compare with this one. Okay. See how this model is so small. I think definitely our problem is that we need to reduce the size. Okay. $100. Yes, 100 is fine. And then 200 is too much. 550 is way good, way better. Then what it will be is it will be 550. And then here 150. 2784 784. Let's make it 100 and let's make it okay 150. Okay, let's see 150. Dropout. We don't need dropout for now. No, we don't care about dropout now. 10H. Let's keep it. Okay, rain is coming from my window. I need to close my window. Okay, my roommate again laughing. I don't know. So here, this model is small now. So let's calculate the size. 100 to 56. 256. It will be 256 256 00 plus 256. 256. It will be roughly what? 25? 26. Let's say it's just roughly 26,000, okay? 26, 550, and this one is quite small, right? Quite small. And that's good if it is small. Guys, who can calculate this quickly? Okay. If you need to calculate this quickly, then we can just open this small Python stuff. And then, oh, no. In MacBook, if you have MacBook, we can say just 150, 784, 784. Okay, it is 117. And we need to plus 784. 118. 18. Okay, 118. Then done. So what is the overall size? It is overall size here will be overall size 18 1314. Okay, overall let's say overall size is 145, right? 3 4 145,000 parameters, okay? Roughly. I know it might be a little bit more or a little bit less, but roughly that's our value. And now, important thing is that let's make it small. Two, 5, 6. Output dimension is 2. Why 2? Is because I made such change that first row means, I make such change that output should be 2-dimensional. If the column first is should say probability. No, maybe that's a problem. What if I make output dimension 1? Okay, that's another question. That's another thing. Maybe I am a bit confused about that. Okay, now our model is quite small, right? 25650. 25650 and 2. So what is the size? No, this is big numbers. We don't want to play with that big numbers. 256. $200,000. Okay, almost 200,000. This is what, 550. Small. And what about this one? It's also a small number. 256 times 50 plus 50. 256 times 50 plus 50. 12,000. Okay, 12,000. 212,000 then. 212. Okay, now we have some big numbers. Now it's a bit flexible, I would say. Oh, why we have some? I think my stream is unstable. Now let's compare. Let's see the results. I think our model is still big. Still big. I noticed the one pattern that, for example, see how all of them are same. Because we have so big model that it learned like it doesn't have this flexibility in learning some let's say some patterns, but it learned everything at once. But here also we don't have this flexibility, right? So I think you understand what I mean. So here, for example, this all seems same, right? So it means this is not catching the good thing. It's not catching what we want. Because eventually we need to make this condition influential enough to tell the model to give us the value. So for example, so in this model is that I'm giving a noise, uniform noise. No, not uniform, just a random noise, Gaussian noise, I think, between -1 and 1. And I'm giving this to the model. And in addition to that, I am saying, okay, here's the noise and here is the condition. I am saying, here is the noise, here is the condition. You need to print me 1. And when I pass this one, the model should give us result of number 1, digit of number 1. So that's what we want from this model. I mean, it learned what is 9. But man, I don't need that 9. So who generates 9? The generator. So generator generates this one. So it means I think we need to implement another loss function. Because our just loss function, our on generator, our loss function is the discriminator actually, right? So we need to dive in. I need to bring some water. Okay, bismillah. So here, guys, problem is with loss function, okay? I mean, here it learned perfectly what is 9. That's good, but we don't need that one. And that's fake, it's not good. Okay, let's break it down. For readability, I mean, first of all, let me to write down what we will do. So we need here the max out proof, my implementation works, right? Or it is wrong. And second thing, I want to try with linear layer. No, I want to use discriminator last layer as 1 digit. Okay, good. I don't need to touch this stuff. Getting noise is fine. This train discriminator. We have 0 grad, definitely. We need a 0 grad. Train generator. Okay, we get the output from our model, this generator. So it generates a number, and my discriminator should say it is. So I am passing the generated output and corresponding y. So here, discriminator should say. So here, discriminator should say that it is fake, right? It's generated or it's fake. But in addition to that, my discriminator should also think that does it match or not. So here, discriminator should think very, very carefully and give us a result like if generated output image is like, let's say it's just 1, but our y is 9, then discriminator should say it's false, it's fake. Okay. Model real x and y, real x output loss. I think, my output is not good. I mean, we are making it trivial. No, we are making it not trivial. We need to make it trivial. So let's make it simple. We will have only one output, and it will be 0 or 1. Okay. In that case, when we are training the discriminator, okay, we will get the result, right? Real out. And -1 times real out. It seems it is same. Sum. One minus sum. So our loss is -1 Oh, hello, Blink. Do you do lead code? I do with friends when I meet with friends, but I don't do it usually. I'm now focused on implementing papers. So this guy will return only one-dimensional output. So then we just don't need this stuff. But eventually, we didn't do anything fancy here. We didn't do anything fancy here. So we may have bugs in different ways, in a lot of different ways, but now we implemented this discriminator to output just only in one dimension, or 0 or 1, and we need to debug. We need to find the place who is making a problem. I see. Is it self-study or for work? It's self-study. It's self-study. It is not. It's not for work. At work, I'm doing a much complicated thing. Actually, we need to try different models and see how each of them is working. In my city, it is raining so well. Even though it is Sunday, the weather is so awesome. Maybe we should try lead code, you know? Maybe next stream or another stream, we need to try lead code. Lead code is fun, but we need to start slowly, you know? Like, we should not jump to the hardest one from the beginning, or it will be, you know, our day will be bad, you know? So, here, I want to see actually output here. Let's use f strings, and then I need the loss item. What does it mean is that I was thinking of taking it more seriously for interview. Yep. So loss, so it will be how discriminator knows real image with respect to label. Okay, that will return the loss of real one, how it learns that one, and then how fake, let's say not knows, how detects G image with respect to label. And then here we need gen loss dot item. So guys, I think my internet is bad now. Guys, I think my internet is very bad now. Sorry for that. But if you have any question, don't hold back and don't be shy. Ask questions. How G fools D. Let's make our life more sunny, more productive, even though it is raining outside. It's raining outside. Let's go, let's go. Let's go. So discriminate. Wait. Okay, we made a mistake. We made a mistake here. We have a bugs. So discriminator has problem. It seems like I'm misunderstanding something here, you know. So in real output, if the output is close to 1, it means it is correct. In that case, there should be no change. In that case, there should be no change. In that case, we should add... Oh, what we did? In that case, we need to, you know, we need to say 1 minus. In that case, it will be 0 influence. If we do, if real output is 1, closer to 1, and if we do 1 minus 1 0 0, then sum, it will 0. Minus 1 multiplies by 0 means 0. In that case, loss backward has very small magnitude, or at least nothing, like at least something, but usually it is not a big deal. And here, if it is 0, it is good, you know. If it is 1, it means not good. So it should go like this. And in generator, I want this disk out to be what? So generator should generate such ideal, like how can I say paranoid? No. Paramount maybe such kind of word. Paramount images that we give to discriminator. The discriminator should say it is 1, you know. 1 means true, 0 means fake. Should say 1. If it say 1, then loss will be big. No, we should say 1 minus. No. If it is 1, our discriminator should say it is 1, which means it is correct. Okay, if it is 0, it means fake. If discriminator output is 0, it means we don't do any loss backward. If it is 1, it means good. So 1 minus discriminator output remains. So with that spirit, let's continue. Nope, nothing changed. Minus 64 stays as 64. Minus 64, no change. And then the question comes, why no change? No change means when we are doing backwards, there is no change. Our model here is generator. What? Why I'm passing this model to here? Our model here, it is discriminator, okay? Negative log likelihood. We have logs of max, log likelihood. Okay, we are wasting some time. We should hurry up. So here, discriminator 1 minus real out has some kind of shape. pdb dot set trace. Okay, we have real x, okay, real images. This is the shape of this one, and we have y. Okay, and then I am saying model, okay, and now we have output, real out. So real out has all 0. That's a problem. And why are you giving 0? This is our loss. In that case, this when we do backward, this minus 64 should decrease, no? It's also 0. Why our model is always returning 0? Okay, we need to debug this all, and we should do it fast. I don't want you to return where I am. Okay, H and Y, please return that one to us. We don't need log softmax. We will do it afterwards by ourselves. And let's go one more time, and then okay, continue. So then the real out. What is the output? What is the dimension? I mean, what is distribution? So we should check maximum. What is the minimum? Okay, so now we are thinking about we need to try with negative log likelihood, right? Or do you think that we need to return different thing? Torch dot nn dot functional dot softmax. Okay, what we can use instead of this softmax and log? Let's go to the paper. Not this one, this one. Open with preview. Okay. Tools. Draw something. Where I can draw? Okay, now I activated it. So for G it should minimize, for D it should maximize. Discriminator, okay? D output, and we should take log of the dig output. And this E, what does this E means? E C could be. Okay. Single scalar representation probability or that X. Okay. Generator is this one. Log D on X. In that case, guys, let's not use softmax. Actually, I'm not sure. Let's go with that one. I mean, I'm not that much sure what we can do. What does softmax do? Softmax converts things to probability. That's what I know. Based on other outputs. If I take log of just this real out, then I'm getting nan values. Why I'm getting nan values? Because they are maybe that because they are negative. From negative we cannot get loss log. In that case, what we can do? What about if we put ReLU in between? Good idea. Yeah. So what is this? Discriminator, right? Discriminator, and here we are saying let's put a ReLU between. So it will return, it will guarantee us that we will have only positive numbers. And then we are saying when we are trying discriminator, we need to take log of that and then sum of them. Take log of this, but 1 minus. I think it's here we should say 1 minus, guys. Okay, I need to prove it, right? Why I'm thinking like that? In cross entropy, we have -1 times log of that one because in the real out I expect real out to be positive thing, but here we are getting negative -2 minus, but I want it to be positive. If it is minus, then it will be plus, it will be big number. So this 1 minus our minus negative value, it will make the, how can I say, it will exponentially will help us to grow, help us to have more big number. Now why we add -1? Because we won't make it positive. -1 times, then 1 minus -2, then it means 1. Then 1 minus -2, then it means 1 plus 2, 3. Then it doesn't make sense. It doesn't make sense. It doesn't make sense, guys. I'm sorry. What about here if I add 1 minus? It was somewhere we need to add, or there or here. Let's say I want this guy to have number 0. If it is 0, then everything is good. If I say 1 minus, okay, we have real out, and minimum should be 0. Oh, okay, we have more than 0. And then if we take real out dot log, we have these values, and there is no non values. So then it is fine. And then say real out dot log dot sum, negative value, and I am saying -1 times this -88. It's making it positive 88, and then when we do backward, it kind of gave us good positive magnitude, let's say. Not positive magnitude, it seems like trash talk. When we do that, our loss comes from positive side, and therefore people use -1. Let's continue. This is our generated out, and from generated out, dot log. Okay, we have negative stuff. If we increase it, we will have positive thing. Oh, the most positive is -1. What? Actually, what was the log? Let's say torch tensor 10 dot log 2. But you see the log returns as these numbers, but we need to, you know, we need to categorize them. Do I have here softmax? So max, no. Hmm. Ten zero. Here, before log, I think we need to say softmax, because softmax converts this distribution of our data to the probabilities. We need that one in discriminator. So real out dot softmax dot log. So when we do softmax, if we have positive value, no, it depends on the largest one, right? Negative value get a lot of attention. This is softmax, okay? they're very small numbers, except this one, first one. Then we need to take log of that one. Then everything is kind of negative. They're positive. No, they are negative now. So let's say I have output comes from 1, 0, 1, minus 1, right? So we have such kind of probability, right? Then if I apply log, yes, if I apply log, it means minus 1, minus 2, minus 0.9. We have minus 3, minus 2. If minus increases, then it means they are bad. If minus is 0 comes to 0, then it means torch.tensor.1.log means 1, means 0. Okay. Infinity. Okay, we have bugs. Why it's not learning? Why? What's going wrong? What? Gen out should be positive always. Why are you returning minus 0, 0 then? Understood. Because I don't have a relu, it is leaky relu. Why it is so hard to train these neural networks? Ah, guys. Do I need 10H? Maybe no. Maybe yes, maybe no. What does 10H do? I don't know. Hyperbolic parameter, hyperbolic function, I know. This hyperbolic function. Now I have infinity. Why infinity? Why, guys? Because it's 0, 0, 0, 0, 0, 0, 0. Because it's 0, 0, 0, 0. الو السلام عليكم كيف شمسس وعليكم السلام كيف Okay, guys, sorry for introduction. So I had a call from friends. So we have here some problems to understand. So we need to figure out. I know I invested a lot of time. So anyway, so here nope. Hello gamer GPT. So here what is DX? Multi-layer perceptron. And take a log of DX. Yes, log of dx if x is from the data distribution. log some. You know what? I don't care about this -1. I don't care about this -1 either. Why you do, bro? I am implementing the conditional generative adversarial networks, CGAN. So I wrote here the code, and now I am trying to make it work. You know, like there are a lot of bugs, and I'm doing it from scratch, so there might be so many bugs. So that's it. It's funny stuff, but it's challenging. There are many bugs. We need to have very good patience. So here, get noise, get real data. In discriminator, I disabled. Okay, I have a ReLU, right? Let's say we don't have a ReLU. We don't care about your ReLU. Okay. If I need ReLU, I will do ReLU. I don't need ReLU. Okay, I have this real X and Y, and then I have a real out. And this real out is 64, and I want to see the real out. This comes from multi-layer perceptron, so there is just one number for each of them. So we have here minus, negative stuff, and positive stuff. And if I want to take the log of this, it is very dangerous to do that, because I will get NaN values. So how to deal with that NaN values? So one option to deal with them is to give some kind of function to ignore these values, or not ignore. I mean, we can make all negative values as equal to 0.001. So actually, I want to teach the model to never give me negative value. Never. Just only consider the positive value. In that case, if I get negative value, it should increase my loss, that backpropagation should be big, high influential. So in that case, real out softmax makes boundaries between 0 and 1, right? Softmax, really? And then we should take log of this one, -4, and then I need to make it sum, and then times -1. Maybe this works, guys. Why I am using softmax? Because my data is, is not between 0 and 1. It is, it's sparse, it is diverse, we have also -0.1 or -1, and we have also 1, and it may also increase. If our backward or learning rate is too high, it will go and increase that much. And when it comes to the next forward pass, we get these unexpected values, and their range might be big. So to delicately, or to say to carefully deal with them, we are using softmax. What about sigmoid? Good point. So sigmoid makes everything, it also makes everything between 0 and 1, right? We can use sigmoid also, guys. It's everything is near to the 0.5. Good question will be when we should use sigmoid and when we should use softmax. Excellent question, you know. You can see that sigmoid has such patterns that almost all our data is between 0. Like comes to on average 0.5. But when we use softmax, you can see we have one big value and other values are small. What? Yes. The biggest number is 0.019. And that softmax will increase and increase and increase. Do you think we are doing a good job? It is good challenge, guys. I'm happy to work with this kind of challenge because it gives us the ability to understand these networks very well, you know. At that core, softmax. Guys, let's try this out. Let's try. Let's go. And I have one more question. Concern is that this here positive. And maybe does it mean that we don't need to do this one? I mean, if we do backward here, what if I ignore this one? Huh? Guys, I know it sounds stupid, but what if I ignore this all? No. Okay, looks good. Looks legitimate. And here dot softmax 0, and then log. Oh, I forgot. Let's turn off the debugger. Seventeen. Minus 30. It's not decreasing. It's not decreasing, guys. It is not decreasing. Unfortunately, it's not decreasing. Why it's minus? Look, 1 minus d g z. This is generator output, discriminator output, and then 1 minus discriminator output. Ah, I see. Here, guys. Now look, okay? Now we take a minus, look. And then log, and then sum, or etc. It means. Up. Okay, now it should work. I mean, if it doesn't work, we will debug more. Nope, it's not working. I have low battery. Can you hear me, right? Okay, you can hear me. Okay, good. Okay, we have now plugged in power. Okay, our loss is not decreasing. Here we don't need this softmax 0. Why I put this 0? Because I only return only one stuff. If it is 1 and if it is 0. Okay. I have only one input. But I cannot take this log because it is dangerous. Because taking softmax from 0 dimension is nothing. It's useless. Oh, okay. It's my fault. What now? Let's try one more time. Good. So, real out, right? It has different shape, different size, and it's individual, right? It's individual. Let's make it page size just 4, and then we can have negative values, we can have positive values, and they change usually. Good rule of thumb is to treat all that negative values as small positive values. In that case, how we do implementation? Torch dot max, or we do real out, or torch tensor 0.001. Okay, this works. Maybe this is fine. So if I do this one, and then we will get rid of the problems with nan and log nan infinity, and then I just take the log of that, and then sum of that, it will be negative value, and then times -1. Okay. In that case, real out torch dot maximum, and yes, real out, but then tensor torch dot tensor. Our minimum is 0.0.0.0.1. Let's do like this. Okay. This is legitimate. Okay, this is. I yesterday learned one good word, you know. What was the name? What was the name? Cynical. Cynical. That's a good word, you know. Good word, but you know, like people don't use that usually. Okay, we have this out max, and then negative. Let's introduce a function. No, I don't want to make it complicated, you know. I want to keep it readable, make it readable. It is not real out, it is, I want to make it gen out to be torch max dot gen out, or tensor, or torch tensor this much. Okay, and then 1 minus of that one, and then the log should be legitimate, and then disk out. No softmax, stupid stuff. Who told me to do this one? It is very stupid. Disk out is equal to torch dot tensor. No, torch dot max, and then disk out, and then torch tensor 0.00001. Okay. Wait, let's continue from new. Okay, real out. Okay, what is our loss? 46. Okay, next one. Again loss. Item 4. Wow, that's good. How D knows real image? Oh, that was so stupid. 166. Okay. Okay, we have a real out. It might be 0, it might be 1, it might be minus, it might be positive, it might be 0. Torch.max. And I'm using this one and I'm omitting, I'm ignoring the negativity, I think. This is one implementation, let's say. Second implementation which comes to my mind is but when we have a 0, it might be very small problem, right? What about now? If I use such implementation, negative things become way more positive. What is the issue with the model? Issue is that my loss now is returning negative 26. It gradually becomes more negative and it shifts to the negativity. So the problem is that this model returns us just one digit, and the digit might be negative value or positive value or 0. And when I apply a log, as you know, if this value is 0, then log will be infinity. If this value is negative, it will be nan value. So I need to handle that situations, that conditions. So in that case, I'm using the power of 2 to get rid of the negativity, but it's not what I want. Because the real out, I expect it to be between 0 and 1. Let's try with this one. Anyway. I normalize image, but I'm not normalizing output. Do you think we should normalize between, for example, let's say our model output, let's say for this update let's say it outputs the minimum value is, let's say, 0.9 and maximum value is 0.3. So then if we normalize between 0 and 1, maybe it's good. Maybe we should try this one. Good idea. If we normalize this one, it will shift this -9 to the 0, and the maximum it will convert to the 1. And how it will handle the backprop in that case? Okay, so let's try the normalization. Good point. Thank you. So then real out will be torch dot. So if I want normalize, it was in torch, it was clip, right? No. Let's say our x equal to torch rand n. Let's say I have 5 values, okay? And I want to normalize this between 0 and 1. In that case, torch dot clip x 0 1. No, clip means no, clip doesn't do that one. Clip just cut everything. We need to shift it, right? So we need the function. Just normalize. Yep, you are right. I'm using negative log likelihood. Yes. This is classification. It's classification. It's binary classification. So I know this is messy. Sorry for this one. So so I have discriminator. Discriminator should return me only from this one, from this linear layer. It should return the just 1. And this is implementation. I'm not using this log softmax. I'm ignoring it. So this one is output of multi-layer perceptron, and shape of this one is 1. Page size and 1. That's it. And for loss, I said I'm taking the log. I want to take log of that one and make it sum and multiply by -1. There is shift, right? No shift. Do we have shift? Torch, shift, torch, move, torch, cleave, torch. Okay, I need to check torch. Instance, no. Cleave future. P2. What does 2 means? Oops. No, it's not what I want. It's not normalized. It's not what I want. I want to shift. This is definitely that kind of function. Storage. Let me to make it by myself. So we have X, right? So X is this one, and then I have minimum, and I working on generator or the critic, auto criticality, and what I trying to do. So I was trying to implement this conditional GAN, and I'm not touching the model yet. Model should seem so fine. I'm just trying to make the loss function good to let the model learn, because the loss function is not decreasing and loss value is not decreasing when I am training. So there is some kind of bug that I am not catching, maybe something stupid or maybe something serious. So if loss function is not decreasing, it means back propagation is not working very well, and if loss function is not decreasing, it means, or if loss function is static, it means weights are not updating, weights are same. So let's say I have a range. So I have a range let's say I have a range of minus 0.2 and 3, right? I want to make it between 0 and 1. In that case, 3 should come to the 1, right? And minus 2 should come closer to 0. Three divided by 3.2. Minus 2 divided by 3.2. No. Are you rolling out your... Oh, where do you use Torch Autograd? I'm not using Autograd, I'm using just backward. So if you see this one, I'm passing the discriminator to here. I'm giving the data and optimizer. And then 0 grad, as you know, then I'm doing backward. So when I do this backward, the value of loss goes back to the initial value. So the gradients become some kind of value instead of NAND. And then I do calculate the loss for generated images, and then I add that backward also to the gradient, existing gradient. So gradients doubles or gradients become bigger. And then I am just doing optimizer.step, which means take these gradients, take the learning rate, and update the weight. But the loss is not updated. The loss is static. Currently, it's not static. Currently, it is fluctuating. But it seems like I'm not getting something very trivial. Because, yes, if we know that model return may return -9 or negative value, or even 0 or positive. So I need to handle that stuff gracefully. So as you said, normalization seems good approach. So in that case, if I want to normalize, the minimum is here. Minimum here it is minus 0.2492. Maximum here it is what? 117.35. And I want to normalize a mean is equal to 0. No. If it is 0, it is also not good. 1. Yep, I'm making something stupid. Let me to check the internet, okay, guys. We are wasting some other times, so let's go to some repo, okay. Oh, let's see what they are doing. Okay, discriminator return just one value, linear layer. Okay. So what they are doing with that one then? We have a discriminator, and then discriminator CUDA parameters. Okay, discriminator goes here and we get validity. It is bn1. Okay, in that case we put it to the loss, adversarial loss. And what is it here? But he's using mean square error. Guys, I can use mean square error. Why should I care about negative log likelihood and etc.? Where I can use mean square error. But it is question of classification. Okay. Wait, we need log. I can use mean square error and I can get rid of these negative values. I can handle with negative values with mean square error. But actually, is it the best way? Is it the best way to handle it? Is it the best way? Let's check the GAN, just simple GAN model. Sigmoid. Nope. Sigmoid. We can use sigmoid. Sigmoid. Real out. Nope. X dot. Okay. I come up with the idea of using this sigmoid. And then if I use sigmoid, guys, and then if I take log, it makes trouble. No. Why it's not making trouble? Torch tensor. Let's say 0 dot log. Okay, 0 should be the float. Infinity. It means that it's not infinity. What? I'm using sigmoid. Let's try with sigmoid. We can do it. We can do it. We can do it, guys. We can do it. If I make some stupid problem, stupid mistake, please give me hints, guys. We can do it. We can do it. Okay, we exit it now. CGAN. Okay, now I have output. So this is my output. It's all positive. It's good. So now if I apply sigmoid, let's see if I apply sigmoid, the output is what? It becomes near to the 0.5. It's good. Then we need to take log and sum and -1. Let's say real out dot log dot sum negative value, and it will be positive. Kind of works. Okay, in that case, how it will influence this negative 2.4? This negative 2.4 means overall, right? Or means total sum. And then real out dot log dot sum. So if it is 0, like for example, to sum it should be 0, the log should be 0. When log will be near to 0? When real out is 1, right? When torch.tensor is equal to or near to 1, the log will be 0. Yes, in that case it works perfect. And we want that one. We want to decrease that one. And then next, loss item. Loss item 2.4. Good. Let's go. Oh, I forgot to apply it here. .4, 2.9, okay. .39 and 2.97. Seems working, guys. Seems working, guys. It's good. Where I am. Wait. Then here. Oh man, come on. Okay, loss discriminator dot sigmoid. Continue. Up. Oh, it's increasing. No, we don't want that one. We need to be decreased. Okay. Seems working, guys. Seems working, but we should check it. We should check in big scale, in height, in big scale. Yep. Okay, it's late. That's good. That's good. It's very good. Oh, generator is also doing good job. Fooling. Aha. Okay, good. Maybe I need to increase batch size. Batch size is 4, you know. Just number 4. And oh, it was generated in the morning. It's what we have now. No. What we have. Alhamdulillah, guys. It seems working. It seems working. Bitch. Nope. Bitch. Why, bitch? I really like this GAN model because it gives you this good sense of AI than using this simple supervised learning. Supervised learning is kind of not fun, not interesting. You don't learn that much, and it's not that fun. But this GAN, they are so fascinating. Okay, we are training so many epochs and still we don't see any good results. Because discriminator is doing good job. No, wait. -1 real out log, right? Sigmoid log sum -1. I mean, here it says it's learning what is generated. I think here discriminator is doing something not as we intended. Wait. Okay. This discriminator model should give us disk output as 1. If it gave us as 1, it is good. In that case, one minus sigma 0.5. I think I need to remove this one. Why it's so confusing? Where I am? Okay, man, stop. I want to test one thing. Okay, now we can go. Now you can go. Please start again one more time. Yes, guys, now it seems fine. Oh, how difficult this things, but how it is interesting. I mean, exciting to see this stuff. But see, it's all same. in the end, I want a model which I will give a noise and I will give a number, let's say 1, and it should give me the number 1. And we are not using the mean square error. We are just using cross entropy. I don't know what is shipovnik. Shipovnik in English. Rosmarin? No, 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 not rosmarin. Shipovnik, shipovnik, shipovnik. Ah, rose hip. I brought rose hip from my hometown, so I boiled it in the fire and I put into a refrigerator. Now it's cold. It is juicy. Wow, it means it's working good. Maybe we should play around with the learning rate. This should be here. We should take this one. Or maybe we should increase the size. We should make the model stronger. Wait, it's all same. I see 7, I see 9, I see 1. I think our loss function is perfect now. Now we should tune some parameters from the model. Okay, as you can see, generator seems doing bad job. Now we can trust our loss function results, and now we can think about what we can do with this generator to increase the capacity. Do they mention about the size? No, they are using different model. Oh, they have size. Generator noise size 100 to 500. This is another mod. It is not the MNIST. Oh, we got NaN values. Let's make the model size small. The generator. From 100, let's map it to 512. Let's make it 100. I mean, let's make it. What if I make it 1000? Generator is flowing very well. I think our model size is so big. That is enough. if our one model is smart, another is not smart, it hurts. What? Now let me to change this evaluation stuff. So in evaluation, I ask it to generate noise, right? 144 plus that one, add for this guy. $114 times. Tensor. And then I for I in range 10 times. So I will have how many values? 10 values, right? If I do 10, if I do 12, it will be 120. 140 and 4 and plus 1 2 3 4 plus 0 1 2 3. And let's say, what if I don't print this stuff? I mean, what if I don't print this one, just print the biggest one, the at the end of the in the end of the loop, train loop. It's not here. Generator is kind of fooling quite good. Okay, that's good. That's good. No, it's not what I want. It's all same. I don't want same stuff. It's all same. I want, you know, like 0, 1, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 0, 1, 2, 3, 4, 6, 7, and 10. It should go like that. And let's use Adam. Not this HGZ. Discriminator is not fooling. It's not doing a good job. Discrim generator is not fooling either. Oh, epoch 3. Ah, we have small dots. Why it's all same? Well, I am too slow. Why? We invest 2 hours and we have no results. And what we can say? Our discriminator definitely cannot differentiate. Oh, it can. It can differentiate data. What is this? What? As you can see here, our problem is this. Discriminator is suffering. Discriminator is not learning very well. I mean, they are not equal in learning. Discriminator is not learning very well, but generator is learning very well. Generator is strong. So, guys, I think a good idea to try is to increase the ability of discriminator. Okay, what about now, guys? Now what I did is that I increased the number of neurons for the condition y. Look, generator is big number. Okay, they are both small number. It's again big number. Oh ho ho ho. Let's check the results. Funny. You know, this one should be 0, this one should be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. I mean, no. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 0, 2, 3, 4, 5, etc., 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 etc. Discriminatory again 9, 5, 7, 7, 8. But here it's doing good job. Page 20. I think our loss function in discriminator is weak. Or we need to reduce generator. What do you mean to reduce here? Everything is fine here. Nope. Nope, 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 nope. We're gonna try that something different, something different. Okay. 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 Ha. No, 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 no. Now I increase the number of linear layers in the both models. In both models has a big linear representation for digits, but it seems it doesn't make sense at all. I think rule of thumb is that this guy should only give me 50. Yeah, just 50. Okay. Done. And this guy is also should give me 50. Done. Plus 5. Plus 5. Replace 1. Actually, why 50? Why not just 10, guys? Ten neurons, 10 neurons. Now generator is smaller, and 1. Generator will not go down. It will not go up now. It will just go down, down, down. Oh, now it go up. Now down. Ah, it's sick. Not good at all, not good at all. 15. I don't understand why this goes 15, 18, 14, 9, 9, 7, 3. It means discriminator is not getting something. Oh. Op. This is secret, guys. We should not look to this. It is private terminal. No, for generator we need to have. It's easy for generator. Look. Generator depends on discriminator, right? If discriminator says it is fake, it's fake. But if what if I add new something something new? For example, let's say how do I know incorrect names then? Oh. From generator we have output, right? So discriminator should give us whether it is correct or incorrect, right? We have two options. We can either reduce complexity of generator or increase the complexity of discriminator. xy equal to self dot drop out. Oh, I forgot. Okay, we did both of them. We increased the complexity of the discriminator and we decreased the complexity or overfitting of the generator by implementing the dropout. Stupid. So here. Let's introduce here also dropout. Do I have dropout? Need to check. Yep, we have dropout of 0.5. It's big number. Okay. Do you want to see pictures? Generator again. For generator, it's very good. No, we are not teaching. We are not teaching. Our model is not learning. We are not teaching as I want, as we intended. Oh, what is this? This was very bad. And why it happens? No, because our model doesn't know what is. I mean, it just generates. So this discriminator guy should be very smart. You know? This discriminator guy should be very smart. For example, if I pass this y, there is real x and pass it on y, you get models. A model based on x and y. So here y is same, right? Or maybe I should not pass this y. What if I omit this guy? like instead gen. I mean, from my point of view, we can omit also. So we have very small number. Very small number means they are doing very well in terms of this evaluation metric. Or what about, I have another one idea to try out, is that we will allow this guy to work, but with one condition, that this y will be random. Hmm. Why I am giving this y rand instead of the same y? Because to tell that this doesn't belong to that one and that doesn't belong to this one, if I give y, it will be maybe too narrow, not diverse. That's at least my assumption. How it goes to 2? So when we are back prop, we got stuck with problems. So we have nan value. Nan value comes from where? It comes from discriminator loss when both of them is nan. It means in back prop we have got some kind of issue. Ha. Okay. Our model is not learning. I need to prepare for GRE, my GRE. It's not learned. It's not learning. Maybe replace with 9. I mean, the more training. I mean, why I need to complicate things, guys? I mean, that's my fault, you guys. You know. 16 is enough. 8 is enough, guys. 8. Seems it is somehow working, but guys, I don't know. This is not what I want. I need to go to the bathroom. Okay, guys, I'm back. I think now it's so big number, such a big number, right? So it means iterations are not enough for this batch size. Let's make it like 16. In that case, it should be small numbers, right? Yeah, yeah. Now it should somehow work. It seems batch size. If you increase batch size, you need more data. Yes, if you increase batch size, eventually your iteration should be way more bigger. If you do such thing, in that case, your learning rate will go quite for a long time, for long place, for a long direction, right? No, it's not the case. Okay, here you can see it's 8, 10, 5, 8. It means it doesn't learn anything. See? So it means it's for 1600 is not enough. In that case, it is. Let's say 16. No, let's make it 4, guys. I'm not seeing the effect of the condition. Let's say the on internet implementation. What's the difference with mine? Let's see the CGAN. I understood their loss function is different. And the discriminator is big. Look, 512, 512, 512, 512, dropout, 512. Quite big, big network. Doesn't matter. Doesn't matter. Doesn't matter. Total divided by 2. That's a good point. One thing I learned from the code is that when we train discriminator, the he called backward, right? Afterwards. D loss equal to gen loss plus plus loss divided by 2. And then in that case it should. So what does it do? It means it makes learning of discriminator less powerful. And I don't want to make the dropout of 0.5. It's too sharp. It's too too much for me. Let's make it 3, okay? I mean, sort or 2 of them, or just 2 is enough also, guys. So generator is not learning. But so first of all, first we are training discriminator, right? But they are training first generator. Why? So in their code, if you look, they train first generator and then discriminator. In our case, we are training first discriminator and then generator. Does it matter? I think yes, it matters. Cut. expand your GPU stuff. Flask. Okay, okay. What we are not able to do is that we are not able to teach models the we are not able to teach the numbers. What is this? Okay, let's try the different loss. Okay, instead of getting sigmoid, mean square error, right? Mean squared error means real. Wait, I don't care about you. So real out. Mean squared error -1, then squared, and then mean. So generated loss equal to gen out -0 squared mean. Okay, I need to add 2 brackets, 1 2. Okay, this is mean square error, and then here this loss is BCE. We need mean square error equals to disk out -1 dot squared mean. Guys, I know it's taking 4 hours, but we don't have results. Interesting, but we learned new things, right? So guys, you learned that we have sigmoid, we can do softmax, and sigmoid is safe. Softmax is not safe in this case. And then what we did just random crack stuffs. So let's check the outputs from 50. So this is what we are getting now. We are using mean square error. Oh, no, it's previous output. It's not our output. This is our output, okay? What's their learning rate? Let me check learning rate. Learning rate optimizer. Okay, it's here. Learning rate 0002. We need to add B1, B2 also, guys. I think this is not good at all. 62 is 1 to 8 is a good number, and then init is fine. Here they propose to use 2. They are saying it works for them, and then betas. The optim. Okay, betas. Oh, I don't want to do that. Sorry, I don't want to do that. So betas equal to what? 0.5, 0.999. Okay. Betas 0.5, 0.999. Okay. Okay. Let's go. Let's go. Wow, it's small. No, it's not good, guys. It's not good. I'm very angry. When I train the generate discriminator, I use the same Y, right? This is real guy. On model, this is fake guy. Gen X based on what? On real wire. I'm again convinced that it should be safe. It should be fine. I think size. Okay, last trial. Okay, guys, then we will complete this stream. Another unfortunate stream. Not unfortunate. I mean like unsuccessful. We would say it's better words. It disguises better. Yep. Mm-hmm. No, what are you doing? 50. What if we increase the magnitude? What if I improve the increase the magnitude of backprop? good thing is not to amplify it yet, but okay. Why it's difficult, so difficult. Guys, it's just the beginning of AI. I mean, it's 2013. I'm doing something wrong here. We should figure out. So, guys, that's end for this stream. Thank you very much for people who watched. I'm not sure whether I give you enough value to watch this 3 hour, no, almost 4 hour video. I spent my 4 hours of my life to this stuff, and basically I didn't get it working. My loss is so small, you know. My loss is so small. What was their loss? I don't have batch norm, I don't have leaky relu, I have just relu. It may matter, it might matter. Okay, last experiment, guys. Okay. I don't want to give up. I want to fight. Fight. Where's generator? Okay, generator. Label. Was a concatenate label noise with label in the beginning. What about if we try the same? X uch, then 5. I know that Relu sucks and that leaky Relu is better than Relu. Okay. 10H and we need dropout. Dropout. Where dropout? What if we try here? Okay. And discriminator. What they do in discriminator? People. They cat in the beginning also. How a smart move, guys. X flatten. Cut. Then X equal to torch cat X and Y. Okay. And then max out. X max out 1 2 3 qilaylik 1 2 3 place 1 and then 7 8 plus 10 to 200. Let's make it 512 and then 512 to, I mean 512 is too much. 256 256 200 and from 100 1. Okay, and then Relu sucks. We need leaky Relu. Leaky Relu, and then should be fine. Yes, now it takes a lot of time to process because our model now is kind of huge, kind of big model, you know, because generator is big, huge. We have this stuff, and this stuff is also expensive. I would say we don't need to increase this one. Make it 100. 100. Let's see the epochs, how is they are doing. I mean, this is risky. See, it's all the same. All the same. Model is not learning. Guys, are you sure that your model is correct? What does it take to me to run this model? Nothing. So let's compare it. Let's compare it. Let's compare. I will run it, okay? Quit. Vim. Cheated. CGAN, okay? Because we are cheating now. Nope. Insert. Oh, we make mistake. Set past, okay, and then insert, and then paste it, okay. Python cheated CGAN. Let's see the images. No, my model sucks. My model sucks. See? What is this? What is this? We need to have. If you open this folder, we need to have images. 1, 4, 2. 1, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Their model is working. Our model is not working. Maybe batch norm. Maybe it's time to do batch norms, guys. It's time to do batch norm, I think. So batch norm takes the tensor and makes and which right outfit and 0.8 0.8 and out 256. how their model is perfect. I think I can also. For me to implement batch norm is not big deal. 256.0.8. This is done. This is batch. I mean, I just need to import stuff and then make small calculations. 256, 100. Oops, sorry, 100. Then we have batch norm. And what else? What else? Oh, their linear is big, you know. Oh, batch norm 1D. Yes, of course, 1D. Okay, 1D is with small letter. 1D, and then let's check it. Running means should contain or not 100. Okay. Where? Train generator model. In generator model. In generator. Beautiful. Beautiful. Their model is working. Their model is working pretty awesome. Thank you very much. Thank you very much for your hard work, and I want to see my model. This is my model. Epoch 8. Okay, it's not generating quite well because So what's difference between their model and my model then? Okay, their discriminator size is big. Mine is 205, 256, 256, and 100, and from 101. I'm letting it to get big, strong ability to memorize. Okay, so the code from the internet is working, but code which we built for in 4 hours is not working. What is the reason behind that? My loss function is same. Do you want me to prove? Let's prove it. So they are using torch stuff, and then let's say I will have output torch.tensor torch.rand, okay, rand, and this is our output, okay, and then they are using torch.nn.mean square error loss, and they are saying off.x and 1. They are using like that. MSC loss, serial loss. Okay. 1. Everybody is 1. Okay. And I'm saying x minus 1 squared doesn't mean This is my implementation. Loss is fine. Am I missing something like very very stupid? It might be that if you how can I say, if you sit in front of computer for a long time, you will be so dumb that you cannot solve even small arithmetic problems also. So you need to refresh yourself, you need to hydrate, you need to go outside, do some exercise. Okay, so generator. Okay, I am calling backward. I'm calling here also backward. I'm calling step backward. Then should be fine. No, it's broken. It's broken. So all is broken. So angry. I'm so angry. When we train this generator, we get feed generated image and generated label. Yes. When we train generator, we generate both of them and we feed of them and we feed and calculate that one. Yes, this is what we are doing. Same thing, same stuff. Backward and step. Okay, okay. And valid. Float tensor. We have label and real image and discriminator check validity, and then validity and valid we are checking, and then fake. Detach. Why you are using detach? Generated label. Why he's detaching? When we are given to discriminator generated images, we use detach. When we use generated images when we are training discriminator, when we generate image real x generated x dot detach. Why? Detach means just move out of the CUDA. What if I just delete this stuff? Let's try this like in this order. So it means we are doing one iteration and another iteration on another one iteration here and one iteration there, one iteration here, one iteration there, one iteration here, one iteration there. So that's small but major change. Major change. Epoxy. Oh, this is ugly images. Oh guys, it seems it's working. It's working. I'm happy. Problem was how we were training. Look, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, okay, congratulations, mashallah. So let me make it crystal clear. Up, 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 up. So then I need this one to be 10, and then I don't need this extra stuff. It is up. Ooh, okay, seems fine. Seems fine. Where I am? And I understood epoch is not matter. Matters is ether. Total ether is equal to 0, and then we will do this one, and then as it finishes. What plus equal to 1? Okay, and then okay, fine. Then what I need to do is that I want to print not at every epoch. I want to print at every. I mean, at every ether. If t ether equal to, let's say, at 200 to at 100. Let's say let's say at 50. Okay. In that case, I want it to visualize. Append past. Okay. What? No, 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 no. Okay. 1, 2. 1, 2. Okay. Fine. Fine. We just need generator. We don't need discriminator. We don't like discriminator. Okay, we don't need this guy also. Then, actually, what is our size? Four, 6, 8. 4, 6, 8. It means it's good idea to print at every 400. Okay, and then at every 416. Guys, done. Next model. So I really want to try this encoder and decoder, you know. Then where we can start doing that? Encoder and decoder, guys. Encoder and decoder. I think in this GAN model they have encoder and decoder, I think. Is it DC GAN? Is DC GAN stand for that? DC GAN. Decoder. No, it's geometry stuff. When it was published? 2018, okay? No geometry constraint. What about cycle GAN? Cycle GAN. Cycle GAN. Okay, it's working. Oh, horse to zebra. Oh, summer to winter. I mean, paper is so fascinating. Oh? No, 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 no. Guys, we made a small mistake. New folder. Oh, what happened? Because here I ask it to save to CGAN, but it doesn't know. It doesn't know CGAN. So we need to retrain, guys. Sorry. So let's check it. So now it's CGAN. It should write inside CGAN. It should write it. And I understood. So then the problem with loss is not it's not a problem anymore. You know, we need one more drink. Okay, we need one more drink. Need one more drink, and then now we need to try with log likelihood, with negative log likelihood, and it should work probably. It should work with log likelihood also. So I think here, let me to create new folder. No, what? I'm here, right? So new folder. Not here, man. Oh, why? Okay, move to trash, and then we come here. No, we come here, and then we say here new folder, and then we say CGAN binary cross entropy. Okay, and then we go here. Wait. Do I making some kind of stupid mistake again? Guys? Okay. It's not what I want. At every 4,000, please write, okay? Okay, I'm done. Okay. CGAN mean square error. At every 400, please write, and every 600, do the let things. Then we need to save it. That's good. And before running, let me to create the rename the folder. Rename CGAN mean square error. Okay, and then we are ready to go. Guys, we did it. It is kind of working, okay? It's kind of working. Finally, you know. And I think we should change the shape. So number of rows should be 10, guys. So then we are happy, because it's too big. So eventually problem was just with our implementation. It means we looked to the problem so deeply that we couldn't see what's near to our eyes. I mean, what's under our eyes, in our nose. It happens. Like, how can I explain? If you start looking to one point for too long time, then eventually you will not see what's around, what's near, and then you will be so focused only on that thing and you miss this stuff, and that's not good. And how we can train this stuff? We need to play games, we need to read books, we need to do puzzles, maybe solve some mathematical stuff, maybe lead code. And another thing is to fight. If you go to boxing, let's say, or wrestling, or something like this combat sport, or let's say UFC, not UFC, yes, UFC. If you go to UFC, you need to consider this both of them. So you need to tune that things in your brain. So that's awesome. Okay, okay. I mean, at what iteration we should stop? 10,000? 10,000 is a good number. Good number to stop. Copy. Paste. Oh, okay, okay. I want to try to. I want to make the model small, you know. But before that, I want to prove binary cross entropy. I want to prove that our loss can be changed to classification stuff. Okay, here it's a bit tricky. Okay, let's see, so it's done, and then I need this one and real out dot sigmoid, and should be fine. Do you think it should be fine? Right. Then first row should be all 0 to 1, 2, 3, 4, 5, 6, 7, 8, 9. I mean, it's learning slowly. It's learning. It's adopting slowly. But this way is also valid. This way is also valid to try, and this way is written in the paper. There was a small mess here, but eventually we come up with good numbers here. 5 is a bit tricky. How is the software sector where you are? You mean the job, right? Job market. If you say software sector, you need to know Korean language to work with to if you want to work in Korean company. But if you want to come to the global company in Korea, it's very very how can I say, it's very competitive, and I would say it's fine. I would say it's fine. Everywhere is something like this, I think. Okay, we got the GAN models working fine, working good. That's enough for today. So I need to go and study more. Actually, oh, I see you are from Korea. Yeah. It's. I'm from. I'm not Korean. I am from Uzbekistan, but I complete my bachelor in here. So I am now doing some internship. Yeah, I know it's. All people always say like that. People always say that it's cooked. That unfair job market is unfair. That juniors are like got lost and AI is replacing. People always say, but it should not like it should not hold you back. We should work harder. Okay, I think model is done. I mean, this model. Look to this model, how it's working beautifully, amazingly, huh? Model is a little bit not getting the number 5, you see? Okay, we are streaming 4 hours. Actually, we need to do the clip. We need to train, we need to train clip. We need to train speech recognition. We need to buy 3090. But I bought a computer and I made a personal server. I installed Ubuntu server. I bought very cheap computer, very old, 2012. I don't know yet how much energy it consumes, but it has a good cooling system. So I'm not worried about like thermo issues because it has a lot of coolers, and it has a GPU inside. But that GPU is so old; it's like 1060 or 960. It's something very old. It has also fan, and I have extra fan. I need to measure the electricity, how much it consumes in one day, in 1 month, let's say, and I need to compare it with, let's say, with Digital Ocean or with that remote cloud systems. But I think it is much, much cheaper. And actually, because I did that one, I learned very well about IP and about networking. I took networking class in when I was in second grade, in second year, in second year. But I didn't practice that well. I knew that what is subnet, what is net, what is TCP, what is OCI, and what is UDP. But theoretically, now I really suggest to you also to go and buy cheap computer, very cheap computer, and install Linux and go and build your server. Actually, we need to go and hack this iPhone. Hack this iPhone and then make it as a web server. But hacking seems so it becomes like state of art to hack iPhones. But hacking Android, I think we can hack Android. But iPhone should be also hackable. In previous streams, I told about that I have an NVIDIA Jetson Nano and Jetson heavier that board, that development kit. But the point with that the memory is problem. Memory is so small. And fan is so crappy and so cheap that it makes so big noise that it starts annoying. And the third thing is that you don't install directly Ubuntu. As far as I understood, you need to go to NVIDIA website and download NVIDIA edition of Ubuntu or of their edition, and then use that one. And then you need to get accept some terms of conditions of NVIDIA and some things, etc., etc. And then I just said, no, it's not my type. I need to return it back to school. Guys, we are having so beautiful results. And now my question, another question I want to know is that we have this BCE, right? And then let's say no, op, and then git status, git add CGAN, no, CGAN.py up, git commit, got working CGAN. Issue was with how I iter over the dataset. I did train discriminator for all dataset, then training generator for all dataset. As a solution, we need to train together instead of training separately in per dataset. Okay, git then git add CGAN mean square error, add all. Do you want to add all? I think no, I don't want to add all. Okay, then we can do something better, something new. That is, let's go to CGAN MSE and then IPython from PIL import image. Oh, we don't have PIL? Really? PIL import image. Okay, we have image. Then what I want here is that I want to take all images and make it as a GIF file, animation. Let's say or can I do this without Python, just in Mac OS? Rotate, convert image, rotate, customize, sort lines. No. Nope. We should try this one. What I want is that PIL image make GIF. Seriously, this is not good. Yes, see? Import path_lib, then for I in path_lib.path, and I give my location. If I name -4 equal to, let's say, PNG, right? It was PNG, then print, oh sorry, and then make give.py, then okay, import from PIL, import image, and then I need import path_lib. Start to use path_lib instead of using the OS, okay? Then for if name, you know, it is already culture to use this one. It's not culture, I mean, we should use this one for file name, for fn in path_lib dot path, and let's say the mean square error, no, CGAN mean square error, and then if fn dot name -4 equal to dot png, and then I want to see the fn, okay, for now, and then please do it. Peter did. Okay. And we need to sort it. We need to sort it. Just wait, I will sort it by myself. Sort. No. Doesn't work. So iter dir, and then no, we need to sort. Python path_lib sort dir. How to sort? So iter_dir, what is iter_dir? No, I need to read documentation. You are lying. Pass lib iter_dir docs. Oh, I can do such thing, you know. What was glop? Glop. Oh, there was my solution. Okay, here. Images equal to this one, and for for index in range 400 to what was the maximum? Where in mean square error it was 100,000. 100,000. No. No, we can do something like, you know, like from 1 to 100 to 3 divided by 100 plus 1. And then image pass is, you know, it will be CGAN mean square error, and then GAN iter, and then index times 400 as integer, and then .png. Okay. Index, okay, should be fine. F. And then I need to read that image, okay? So image means image dot open image pass, and then images dot append image it should kind of work. And then images taking first one and dot saying save, and then cgan mse.png, and then gif, and then we need to say save all equal to true, and then append images append images equal to images starting from 1, and then optimize row no false, duration 100 by 425, right? 25 seconds. If I say 25 seconds, is 25 seconds, guys, it's too long. 20 seconds, 10 seconds. Open oh, CGAN. How we can play this one? I mean, can I play with the duration? Oh, it's not in seconds, it is in milliseconds. 500. Okay, I know one trick. I know one trick we need to try. Is that 500 is too big, too much. It's too 500. Let's make it 300, and then I can do plus and images. This one. Plus images and so on. Done. Why? It gives can only concatenate list. Okay. It can only concatenate lists. Go, 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 go. So if I do something like this, it will return list, okay? In that case, in that spirit, we should continue. And then instead of opening, I can do just go here, and then when it stops, it will stop for almost 1 second. Okay. See? Done. So the same thing we need to do for CGAN means MSE and binary cross entropy. Oh, I wrote it on top of this? Oh my god, I wrote it on top of it. We should not hurry up, guys. It's bad. It's bad. So here, mean square error, right? So we wrote it here, and then we make it here, and then binary cross entropy, and then binary cross entropy. Okay. Oh, okay, done. So now, as everything is fine, working fine. So now we need to. I want to reduce the number of params in the model. Because I do believe it's too much. Okay, this one, okay, fine, really fine. X2. I eliminate X2 in here. So it means X2, X3 should expect 256. I mean 100 is enough, and here 100 is enough, and here also. We don't have it on, so now our model is so tiny. So Python CGAN. Go, man, let's go. We have problem. Okay, what kind of problem? Batch norm. Yes, we should update on batch norm also, guys. Should be 100. And batch norm. Okay, it's model size is small. Model size here is small. But I think it should it will eventually learn. I think it will eventually learn. It learned 0, 1, 9, but not very well. So guys, we are done. So git add CGAN give CGAN mc.gif, then make gif. Okay. Commit m. Let's check the GitHub. Then GitHub bin Odil. So it should be in GAN model. Where's the GAN model? 3 weeks ago. I didn't push it, right? Git dot push. It was how to display image. I always confuse these two things. It should be first rectangle brackets or first the circle brackets. Markdown, show gif. So first it should be rectangle bracket. First it should be rectangle bracket, okay. CGAN with pce.gif CGAN pce.gif. This CGAN is different from original. GAN link. Okay, it's good to close this one and then max out. Max out. Then stochastic gradient descent is replaced by Adam. Max out is done. And then what is this one? GAN link. Okay. And then what is this? After spending 4+ hours, we have I looked choose reference for hints and compare my implementation acknowledge. You know, when it comes to acknowledgement, you know, acknowledge, it means you acknowledge that you can only acknowledge your weakness. You cannot acknowledge your strengthness. That's one good point. Okay. Buggy again. Mnist GAN 512 reduce lr dot give. It should work if I do it md. Okay, guys, congratulations. We have it in live, so you can take it. Pull. Unstaged. What? Git status. What is unstaged? It's unstaged. Git add CGAN binary cross entropy mnist git commit and add latest trained generator. Then we are good to delete this all. How to select this efficiently? Just make it as a file. Okay, yesterday. Okay, CGAN MSE images. I can't see it. Git status help. Okay. Where's my ignore file? Oh. Wait, do I need to do that? Modified CGAN. Deleted. Git diff can in. What is change? Git store can import. Okay. What else? Git delete. Git remove cached CGAN CE mist generator. Okay, congratulations guys, thank you very much. Have a nice productive day. So it's just morning, it's just 12 p.m. So have a good day, productive day, guys. Mandelbrot. Oh my god, Mandelbrot is beautiful. Mandelbrot is beautiful. Okay, guys, thank you very much. Bye bye.